Hi, I'm Fuzzy Manners and welcome to FuzzyTek, the show where I talk about technical, geeky, nerdy stuff. In this episode we'll be continuing on from the Arduino for beginners. If you haven't already seen the first beginner video where I talk about Arduino programming and flashing code, there's a link in the description and up there. So, what are we going to make? Well, last time we blinked an LED. This time we're going to do the same, but we're going to have it blink when you push a button. So we're going to cover input as well as output. I'm also going to show you how to use a breadboard for your projects. If you want to create things, you'll need somewhere to put it, a place to start. That's where the trusty breadboard comes in. This creates an easy way for you to connect things and physically see the connections so you can diagnose any potential issues in your circuit. So, let's look at the breadboard and see how it works. We'll also take a closer look at the electronic components involved with our LED project. This is the breadboard I'm using. It's known as an MB102. It has 830 holes or tie points on it for placing cables and components. The outer strips are used for power, red being positive and blue being negative. In the case of this board, each half of the power strip is connected together as indicated by the blue and red markings. The ones in the middle are connected together in columns. So, for example, 15 and 16 are connected like so, but 15 and 16 are not connected together. One half of the board is also not connected to the other half, and the gap in the middle is just the right size for chips. But we'll talk more about those in a later episode. Let's have a look at the steps it takes to wire up a blinking LED to an Arduino using this breadboard. First, I'll place the components onto the breadboard and then connect up the power. I begin by placing an LED onto the board with its negative leg in the negative power rail. The negative of an LED is the shorter leg. So, what exactly is an LED? Well, it's a light emitting diode. A diode is a component that will let current pass through it in one direction only. They don't always have to light up, but the light emitting ones are the coolest to look at. The positive, longer leg I place into a hole on the breadboard, and then in the same column I place one side of a 330 ohm resistor. The other side I connect to another column on the breadboard. How did I know to use a 330 ohm resistor value? Well, it actually depends on the LED's colour, but 330 is a good middle ground. A resistor stops a precise amount of current from passing through it to the other side, much like squeezing a hose pipe and slowing the flow of the water. Or when you turn down the volume on a stereo using a volume knob, you're actually turning the resistance up using a variable resistor, limiting the current to the speakers and resulting in a quieter sound. To connect power, I place a wire into the ground pin on the Arduino, and the other end I connect to the negative rail of the breadboard. I also place a wire in the 5 volts of the Arduino and the other side into the positive rail of the breadboard. I then connect up the LED to the Arduino by connecting the other end of the resistor to digital pin 4, and it's now ready to use. After providing power to the Arduino, the LED blinks as in the previous episode. Now it's time to try and make it blink only when we press a button. So for that we need a button, a 10k resistor and a couple more cables. The button has 4 pins on it. 2 of them are connected together, and the 2 sides are connected together only when the button is pressed, completing the circuit. To wire it up, I connect one side of the button to the 5 volt rail and the other side to a digital pin. For no particular reason, I've chosen pin 6. Also, connect the same side to the ground rail through a 10k resistor. Now we can open up the Arduino IDE and get the button doing something. Opening the blink sketch we created in the last episode, I'll begin by making the button pin a variable, in case I want to change it later, by adding int button equals 6 above the setup function. Now, in the setup section, I'll add a line so that the Arduino knows that the button is an input. It's the same as the LED line, except that it's input instead of output as the second argument. This is the part where we learn a new bit of code. That bit of code is an if statement. It's pretty self-explanatory in that it runs if a certain condition is met. I find it's better explained if we say it out loud. If the button is pressed, light the LED. In order to have it always listening for a button press, we need the if statement to be inside the loop function. To do this, we'll first remove the current code as we don't want the LED to start blinking when we provide power to the Arduino. We only want the press of the button to make it light up. Now we have a fresh loop function. We can type if, open parenthesis, close parenthesis, open curly bracket, and then press enter. And the IDE should automatically insert a closed curly bracket. This is a habit I have as to not forget to close things in my code. Now I'll go back and fill in the statement. Between a parenthesis after if, I will type digital read button equals high. This is just like digital write, except that it reads the state of the pin instead of telling it to go to a particular state. The equals part means equals to or is exactly the same as. In the real world, this means if the button pin goes to voltage level, which will happen when we press it. The part inside the curly brackets is what you want to happen if the statement we just wrote is true. Since we want it to light up our LED, I'll type digital write LED pin high. Now let's see what happens when we upload the code. As you can see from the breadboard, the LED is off. If I press the button, the LED lights up. But wait, it stays lit up. I'll show you why and how to avoid this happening back in the IDE. We have the if statement looking for the button press. But what about when the button isn't pressed? Well, we want the LED to be off. So for this, we can use an else statement. After the closing curly bracket of the if statement, we can type else and say inside it, digital write LED pin low. Now we can upload the code once more and test it out. Now when we press the button, the LED lights up and goes off when the button is no longer pressed. If you're looking for ideas to practice, why not try having it work in reverse, so the button turns the LED off instead of on, or having the button turn the LED on for a set amount of time using the delay function we spoke about in the previous episode. I hope this is helpful. If you have any comments and suggestions, please leave them down below. If you like this video, give it a like. If you don't, please tell me why. And if you haven't already, please subscribe and press the bell. You can also stay up to date with everything over on Instagram at FuzzyTek Show. Thanks for watching, and until next time, bye bye. You can also stay up to date with everything this one will be following on from that and continuing, obviously because it's following on. Breadboards, was that even a word? I'm going to be talking about Arduino again. This one should be good. Bang, that's the one.